So now we want to consider lopsided local lemma. Recall that last time we actually proved the local lemma, and how we prove it is use induction to actually show this relation holds for any s and I. While doing that, we actually use this inequality. Here we have this inequality because S2 is totally outside of this out neighborhood of I in the dependency diagram. So whatever happened here is, AI is mutually independent of whatever happened here. So we have this equality. But even if this is not equality but inequality, the proof still works. So as long as probability of AI when this L, we consider the events which is outside of out neighborhood. If this relation holds, the proof work. So we define that D is a negative dependency graph. Negative dependency diagram for the events A1 and AN. If for every event AI and a subset S, which is a subset which does not intersect with our neighborhood, if we have this inequality, then we say that this is a negative dependency diagram. Or equivalently, you can write that in this manner, or we can even write that in this way. These are all equivalent. So one of these, can be used as the definition. Then as the proof for the local lemma exactly work with this assumption, we can actually, prove the same proof actually yields this. Suppose that D is a negative dependency diagram for these events A1 to AN, and there exists X1 to Xn, such that for every I, probability of AI is bounded by Xi times, you consider all the out neighbor J, and then this condition holds. Then the probability that none of bad event holds is bounded below by the same constant, same number. Or even here what we wanted was not just this, but say this. We can directly actually assume that we don't care about this, but if we know this, then still the proof works. So that's actually extended lopsided local lemma. So that, let's say, this is a digraph. Give me a moment. So and we just have that for every I and say j, we have probability of AI happening when we assume none of the events in J happens is at most xi times this. So this is exactly what we have here. Then we get the same conclusion. So this is also, has the same proof works. So this also holds. So here, we don't need a mutual independence. So if the situation, sometimes in the many of application of local lemma, we use the mutual independence principle, so that there are many independent random variables, and then some of them actually combine to give some certain bad event. So those cases, we can use local lemma. But if the structure is more delicate, that it's not just, consists of the several independent event, but it has more structure, then we might need to actually apply this lopsided local lemma, either the extended one or non-extended one. Next time we consider an application of this to Latin square and transversal, Latin transversal in Latin square.